folks. Welcome back. I am excited to be broadcasting to you today about quantitative research designs. And I got a new headset, so I wouldn't sound like I was broadcasting from the bottom of a well. Okay, today we're talking about quantitative research designs, recognizing the overall plan for a study. This is adapted from Chapter 6 of Yes, Our Wonderful Textbook by Plano Clark and Cresswell, Understanding Research, A Consumer's Guide. Okay, so slide 2. All right. Today I'm going to give you an overall roadmap for understanding 6 main quantitative research designs. Now I know our textbook talks about 5 main designs, but I'm adding another one that's very popular in the social sciences, particularly in education, and also it's popular in counseling, and so I wanted to make sure I included it. And the 6 overall are survey. Well, let me start. We're actually going to go in the order that's from bottom to top on this little roadmap. We're going to be talking about true experiments, quasi experiments, single subject research, causal comparative research, correlational research, and survey research. Okay, let's see what the next slide says. So 6 common quantitative research designs, those that I just laid out for you. And there are 4 key decisions that determine what design the researcher is going to use. Now, are there more than 6 quantitative research designs? Yes, certainly. But these are the 6 most popular in social sciences and professions, like education, counseling, kinesiology, that kind of thing. Okay, so the first key decision is the researcher going to, or did the researcher manipulate conditions? In other words, did the researcher perform an experiment? The second key decision was who the researcher chose to study. The next key decision was what was the focus of the analysis, of the data analysis. And finally, how were participants selected or assigned? So, the roadmap of choices on the way to a true experiment. For a true experiment, the way those questions are answered are: first, did the researcher manipulate conditions? Yes. The researcher studied 2 or more groups. The focus of the data analysis was on comparing groups, and the participants were selected or assigned through random assignment, and that means we have our model is a true experiment. And let's talk a little bit more about true experiments. So basically, there are 2 main types of quantitative research designs. One is experimental research. The other is non-experimental research. Okay, 2 main types. And the only one that's that, to the purist, the only one that's experimental research is a true experiment. Okay, to the not so purist, true experiments and quasi experiments count as experimental research. Everything else is non-experimental. Okay, and we want to for experimental research, basically we're testing the effect of an intervention by manipulating the conditions experienced by the participants. So in terms of education, maybe we're testing the effect of using a different curriculum, for example. Non-experimental research describes variables without manipulating the conditions experienced by participants. Okay, the researcher is in control of what the participants experience, and another, the researcher is not in control of what the participants experience. Okay, that's another way of looking at the difference between experimental and non-experimental research. Okay. Um, Experimental designs. The purpose is to make causal inferences about the relationship. You want to establish a cause-effect relationship between two or more variables. And there are certain necessary conditions for cause and effect relationships. First of all, the cause has to happen before the effect, okay? Or if it's not really cause and effect. Um, there has to be some type of real relationship. It can't be spurious. In other words, uh, there is a relationship between, what's a good example of spurious? There is a relationship between reading ability and height. Taller people tend to be better readers. There is a relationship. Does growing tall make you a better reader? Does being tall cause better reading? No. The fact is that children tend to be short and adults tend to be taller, right? Adults usually have been through schooling that has made them better readers and they have a lot more experience. It's not just because they're taller than kids. Okay, that's an example of a spurious relationship. Um, and there should be an elimination of alternative explanations. And here's where this term control comes in. And so the term control is used differently in researcher language than it is in the usual course of everyday life. And so we're going to talk about this a little bit more, but basically we're trying to eliminate alternative explanations. And so that's when we're thinking about controlling for or for some variable. For example, controlling for socioeconomic status. We're essentially trying to eliminate socioeconomic status as an explanation for whatever it is that we're observing, the effect of our intervention. So here's an example: the keto diet, okay, or ketogenic diet. And one of our wonderful professors, Dr. Holland, here at Augusta University, wrote a paper with colleagues titled "The Effects of a Ketogenic Diet on Adipose Tissue, Liver, and Serum Biomarkers in Sedentary Rats and Rats that Exercise via Resisted Voluntary Wheel Running." Okay, so the symbol we're going to use is the rat. Okay, the rat study is an example of an experimental research. Okay, so adipose tissue, fat. Okay, we're talking about fat. And we're talking about liver and the functions of other organs. So we got these rats, right? And some of them exercised and some of them were sedentary. And what happened was the ketogenic diet reduced reduced how fat they were, right? And you can see this graph shows weight in grams, and then there were three conditions. There was the Western diet, or the typical thing that most people here in the U.S. eat in terms of the amount of protein, carbohydrates, and fats. Then there was the keto diet, which is high fat in comparison to the Western diet, and it's high protein, it's low carbs compared to the Western diet. And then there was the standard chow, what the rats are usually fed, right? And this study showed that you got a reduction in body mass compared with the other diets. The rats were still able to exercise, and the rats that exercised actually weighed a bit more than the rats that were sedentary. I wonder if that was due to increased muscle mass. Um, and Also, they had better markers in terms of things like insulin, which is important for people who are diabetic, right? So Dr. Holland wrote this article, and if you look at some of the articles that have cited it, you see that her research is being used by other researchers as they're investigating things like diabetes, and also investigating even how athletes can lose weight without losing muscle, which is what happens with athletes with still being able to exercise, right? And not fainting away. Okay, so I thought this was a really good example to show you of a research study. I'm sorry, a true experiment. Okay, the rat study. Okay, now let's talk about a quasi experiment. The researcher does manipulate conditions. Yes, there are two or more groups. The focus of the data analysis is on comparing groups. You assign it, okay, so with the rat study, Dr. Holland randomly assigned rats to either being on the Western diet, being on the keto diet, or being eating standard chow. And she also randomly assigned rats to whether or not they were going to have the option of running on a wheel or being more sedentary. Okay, she assigned them to whether they were going to be. If I read it right, she assigned them to whether they were going to be in a cage with a wheel, or they were going to be in a cage with no wheel. Okay, so she assigned them randomly to these different groups. Okay, with a quasi experiment, the groups already exist. You're not assigning them to a group, and the example we're going to use is a math example, teaching math. So, elementary math. So let's say, here's the question. Is a new math curriculum for third graders more effective than your school's existing math curriculum for third graders? Okay? So this is a very plausible question someone might want to investigate. So what you would do in order to judge the effectiveness of two different math curricula is you might randomly assign a large number of third grade classes to either an intervention group, those who are going to be taught the new curriculum, or a control group using the existing curriculum. Okay, so let's think about this. Dr. Holland was able to randomly assign individual rats, right? And basically, we do that random assignment with the idea that we want each group to be representative of the entire population. And we're going to talk about that more when we talk about selecting participants in Chapter 7. Okay, but we're randomly assigning, but we can't randomly assign, we can't just take third graders and just randomly assign them to one math curricula versus another, because third graders are contained in a class, and it's impossible basically when the students are registering for school on the first day of school to say, okay, I'm going to randomly assign kids to different classes, right? Usually as the researcher, you don't have that kind of control. The kids are already in classes. They were assigned to those classes. In some cases, it's district rules, it's their neighborhood, they're already in classes. Okay, and and it's the school administration and school staff who do that prior year, right? When they're deciding, okay, these third graders, what class, these second graders, okay, what classes they're going to be in next year, and then there are, you know, different things. So the researcher does not have control, but the researcher might be able to say, okay, this class of students, this group of students is going to be taught using this curriculum, and this and other groups of other classes are going to be taught using whatever the standard curriculum is. Okay. Then you measure the achievement of both groups of classes, right? These are intact groups. Our groups are the classes. And the difference in math achievement between the two groups, the difference in average math achievement between the two groups, would represent the effect of the new curriculum compared to the existing curriculum. Okay, so this math example is our example of a quasi-experiment. So let's talk about the roadmap of choices on the way to a single subject design. So yes, you're manipulating conditions. In a single subject design, you have one individual or just a few who are participants in your study. You're expecting the graphs of individual data, usually, and that's a single subject design. And we're going to use a reading example for that. So this is, single subject research designs are used when the research problem calls for an intervention to change behavior that is a problem for an individual. And particularly when careful monitoring of the individual's behavior before, during, and after the intervention is needed in order to determine whether the treatment affects the behavior. The individual becomes his or her own control by the researcher, because the researcher is collecting many measurements of his or her behavior over time. So we're looking closely at one or just a few individuals, and we're comparing their growth, but it's the same person, right? So that person hasn't changed. So we're controlling the study. We're controlling alternative explanations by it being the same person. And we plot the individual's behavior over many points of time, and we can visually inspect the data for change, and there are some statistical tests that you can do also. Okay, so here's an example, a teaching reading example. And the title of the article was called "The Use of Assisted Reading to Increase Correct Reading Rates and Decrease Error Rates of Students with Learning Disabilities." Now, why might you choose a single subject research design for something like this? Well, learning disabilities, there may only be a few students with learning disabilities that you as a researcher has access to, right? Let's say you're the special education teacher in a school and you want to see if a particular strategy works. Well, there may only be, you know, 3 dyslexic kids who are at the grade level that you're interested in order to do the study. So what you do is you would teach using whatever your traditional method and measure student performance, and then the intervention method and measure student performance. And these lines probably represent the average performance, right? These horizontal lines. Traditional method, intervention method, traditional method, intervention method. It looks like, just looking at this, it looks like the intervention method was better, right? You can see that very clearly from the graph. And that's an example. So that's an example of a single subject research design. Okay, let's talk about causal comparative. Now we're entering the realm of where the researcher did not manipulate conditions. Who did the researcher study? 2 or more groups. We're comparing groups. And like the math example, these are intact groups. But unlike the math example, we did not manipulate the conditions ourselves as researchers. And this is a causal comparative study, is the most likely research design as a result of those choices. So causal comparative research determines whether an association exists between groups. The groups are the independent variable, and the outcome, the dependent variable. There's no experimental manipulation. Okay. The two groups differ on whatever the variable is, and you compare the groups on one or more dependent variables. It's a practical approach, but you cannot establish, oh, that shouldn't say probably. You can't not establish cause and effect. Okay. You probably cannot establish cause and effect. You definitely cannot establish cause and effect. Let me get rid of that word probably. Let's see. There's the keto. The rat, that was true experiment. The quasi-experiment was the math. Single subject was the reading. And we're on causal comparative. Cannot establish cause and effect, even though it's called causal comparative. All right, view. Let me go back to reading view. Okay. For example, let's say one of your professors has her students complete a survey called Getting to Know You. Let's say she's interested in the relationship between student major and their expected grade in her course. Maybe she's teaching a research methods course. And so maybe the research question is, for a research methods class, do students who are majoring in counseling expect a higher final grade as compared to the final grade expected by students who are majoring in education or kinesiology? Okay, so the researcher did not assign you to your major, right? And so that's how we know that this is not experimental. Okay, but maybe the researcher is wondering about this. A difference between our counseling students and our students in education or kinesiology is often our counseling students were psychology student majors as undergrads, right? And they, as psychology majors, they may have had a research class, and so they may expect a higher final grade. And so maybe the researcher wants to study this. Okay, this is causal comparative. The researcher did not. You chose your major. You chose what you wanted to study in graduate school, and the outcome is your expected final grade, and I can see if there's an association between your major and, on average, if there's an association between major and expected final grade, but I cannot establish cause and effect using a causal comparative. But I could answer that research question. Okay, let's talk about a correlational design. Did the researcher manipulate conditions? No. Who did the researcher study? One group, and the focus of the data analysis was on relationships among variables. And these, rather than being intact groups, generally are conveniently available individuals is how it's thought of. And so we have a correlational study. And this relationships among variables is what distinguishes it from a causal comparative. Mostly. For correlational design, we want to determine the nature of the relationship among the variables, or to use these variables to make predictions. High correlations among variables do not imply causation, just like height does not cause reading ability. And correlational procedures are also used to examine reliability and validity, which we're going to talk about more in a future lesson. So here's an example. I used a smiley face for this example. So let's say two high school counselors want to understand why some of the students in their school seem happy with the school, while others claim that the high school, in the words of one junior, totally sucks. Each afternoon for a week, let's say these counselors stand outside at dismissal and ask students to complete a quick survey. And they enter the results into SPSS, which is a statistical analysis software, and they generate a correlation matrix. And here's what they get. So here were their variables. School satisfaction, number 1. Number 2, extracurricular activities. Number 3, friendship. Number 4, self-esteem. Number 5, pride in school. And number 6, self-awareness. So this is what they're evaluating using their survey. And these numbers represent the correlation between pairs of variables. So here's number 1. We got a matrix. Number 1, this number 1 is for school satisfaction, for extracurricular activities, for friendship, for self-esteem, for pride in school, and self-awareness. And we're going to talk more about looking at this kind of thing when we talk about findings and conclusions. But I just want to give you an overview now. This should say 0.33. By the way, if you all find an error on one of my slides that I don't find before I find it, then email me. I will give you extra credit if it's actually an error. Because that kind of thing drives me crazy. All right. So, okay. So, there is a positive correlation between school satisfaction and extracurricular activities. There's a positive correlation between having friendships and extracurricular and school satisfaction. The self-esteem measure, the higher the person's self-esteem, the lower their school satisfaction. So we have a negative correlation there. There was a very slight negative correlation between school satisfaction and the level of pride in the school. I'd say that's about 0 correlation there. And there is a positive correlation between self-awareness and satisfaction in the school. And you could go through each of these variables and see, for example, there's a high correlation between self-esteem and extracurricular activities, because 2 is extracurricular activities. There's a high correlation between pride in the school and having friendships. Okay, and so on. That's how a correlation matrix works, and that illustrates a correlation study, a correlational study. Okay, so that's the smiley face, okay? School satisfaction, the smiley face, correlational. And finally, let's talk a little bit about survey research. Did the researcher manipulate conditions? No. The researcher essentially studied one group, and the focus of the data analysis is on describing trends in a situation where there was random selection of participants. That would be kind of like the traditional survey research. Now, I want to describe a difference between survey research designs and using surveys in research. Okay, so you can use a survey in any kind of research. You can give folks a survey, right? But I'm talking about a specific, when I'm talking about survey research designs, I'm talking about something very specific. It's a method of collecting information from people about their ideas, feelings, plans, beliefs, social, educational, and financial background. It can also provide information about attitudes, values, habits, knowledge, background variables such as gender, age, or ethnicity. It's cross-sectional. That means it usually just, there are two kinds. It can be either cross-sectional or longitudinal. But one thing to remember is that folks were randomly assigned to get the survey. Okay? If you gave a survey to all of your 7th graders, then that's not random assignment. Okay? If all of the seniors in your clinics in your clinic participated in a survey, then that's not random assignment. Okay, that's not a survey research design. Here's a cross-sectional example. The title was Organized Extracurricular Activities are in-school and out-of-school activities associated with different outcomes in for Canadian youth. And so what they were trying to find out was, basically the different effects of in-school and out-of-school activities. And so they took a population-based sample, okay, and they were looking for associations with having tried smoking, alcohol, and marijuana, and also socio-emotional and academic outcomes. Okay, so basically, this sounds like it was a very large study. It may have been. Often these types of large studies are government funded. So they found that youth who participated in out-of-school activities or in both in-school and out-of-school activities had better socio-emotional outcomes. And then they found different effects for whether they were sport or non-sport and whether they were in school versus out of school. So this is from the abstract. Oh, one of the I don't know how many of you did 4-H? Raise your hand. Okay, a few people. I grew up in Brooklyn, New York, and 4-H wasn't that big a thing there. But I think I mentioned before that I spent a year in South Dakota, and 4-H was a really big thing there. And I went to a county fair, and it was just amazing what these kids had accomplished in terms of, just all different kinds of skills, many of them related to farming. And that was one of the activities that was considered an out-of-school activity for the students in this study. So that's why 4-H is the thing that I want you to associate with this cross-sectional example. Longitudinal example, a researcher might be interested in a follow-up study in the fall of 2008 of a nationally representative sample of teachers who were originally surveyed in the fall of 2007. Maybe she wants to see if their ratings of the supportiveness of their principal relate to whether they choose to stay at their school, transfer to a new school, or quit the teaching profession. Maybe she uses a national survey that was done through the Census Bureau, and maybe she writes her dissertation about what she finds out. Yes. So for my dissertation, I did a survey research. I used survey research, a survey design. I used a survey research design. Okay, so here are some references. Some of those examples were made up. Some of them were from actual studies. And so I'll put these articles online, but here they are, the references for you. And so I hope you enjoyed learning about all these 6 different research designs, and so I want you to remember them now. Okay, so when you're trying to remember what a true experiment is, you think about the rat. When you're trying to remember a quasi experiment, think about that math example. When you're thinking about single subject experiences, think about that reading example. Causal comparative, think about that getting to know you survey. Correlational, that was that school satisfaction, okay, smiley face. And then the 4-H study was an example of survey research. All right, have a good day.